Welcome to InventorCAM Professor on our series of Getting Started. I'm Sydney, your InventorCAM Professor, and in this session we'll be doing our second part in multi-sided machining. If we take a look at this part on our screen, you'll see that this part has to be machined on multi-sides. We have to machine it on this face over here, through this hole over here, which is a completely different homing position, on this face, on the sides. Basically, we have different positions that have to be, this part has to be machined. If we take a look, we'll take a quick look at our coordinates manager, you'll see that we've created different positions, such as our second position, first position. For every single area that it has to be machined, we've created a position, and we've also created a position for milling it on the second side in a different holding fixture. In our first operation, I'd like to machine this face over here. So what I've done is I've chosen my Mac position 1, position 2, and I've chosen the operation of face milling. If I open up the operation itself, you'll see that we have our coordinate system over here. My geometry for the face mill is the boundary around the part here created automatically. The tool that I will be using will be a 16 millimeter end mill. And my levels, we have my upper level of 10 millimeter up until the face depth of this part over here. The 10 millimeters, basically the 10 millimeters on the upper levels to cover the excess material that I have on top. Now in my technology area, I'll be working in a hatch fashion. And if I go into my data, I've chosen to work at an angle of 90 degrees. In other words, going back and forth this way on the part, back and forth because I'm using zigzag. And if I take a look now at my simulation, you'll see that the tool goes down across the part itself and goes down to every level until it finishes that face that had to be machined. In my next operation, I've chosen to work on this face over here, again doing a face milling operation. So in this operation, I've basically done the same thing. I have my geometry as shown over here around the top border of the part itself. The tool, I'll be using the exact same tool I used before. My levels, the exact same options. And in my technology, the exact same thing. As we can see in our simulation, the tool is working at 90 degrees back and forth on the part itself. My next operation, I've chosen to work on Mac 1 position 4 to cover this face over here. And again, I'll be doing the exact same operation and I've done it in the previous two operations of face mill on this particular face over here. As we can see, when I click on the operation, we can see what the toolpath was doing over there. Now, since I'm over here already, I've decided that I'm going to now continue on milling out these two steps at the end. So I've continued on in the same Mac position, and I've chosen my geometry over here to be this line and that line over there. The tool that I will be using will be the exact same end mill I've chosen that I used on the face mills. My levels, I have my upper level as shown over here, and my profile depth is up until the depth of that step itself. In my technology area, I'll be doing a rough cut going down every 3 millimeters, leaving 0.2 millimeters of an offset on the wall itself, plus I'll be doing a finish cut, stepping down my entire depth of the part. Now, if I just take a look at my links, I've decided to approach the part using a lead-in of a tangent of 9 millimeters, and my lead-out will be the exact same as my lead-in. If I take a look at my simulation now, you'll see that the tool goes down and works on either side of the part itself. And if I take a look at my solid verify simulation, you'll see the exact same thing where the tool goes down and mills out both steps on either side. Now in my next operation, I've decided to work back on Mac 1 position 2, and I want to mill out this pocket as shown over here, plus this inside pocket as well, those two slots, and I'll be using a pocket operation. In my first one, if I go into the operation itself, you'll see that my geometry is the bigger slot that's on top. The tool that I'll be using will be a 10mm end mill, and my levels, that being my upper level and my pocket depth up until the step itself. My technology, I'll be using a simple contour option, and I'll be leaving 0.2 millimeters on the wall and 0.2 millimeters on the floor. And besides that, I'll also be doing a finish with this tool, both on the wall and on the floor itself. If I go into my link area, I'll be approaching the part from the top in a helical fashion, as shown in the diagram on the side, and my lead out will be an arc of 2 millimeters. If I take a look at the simulation itself, and again this time I'll use the solid verify simulation, you'll see the tool goes down in a helical fashion and then cleans out the slot, and then goes down to the next step and basically finishes the part up until that bottom step as shown over here. My next operation, staying in the same position, Mac position, to get to the bottom slot over there, I've simply chosen the geometry of this area over here. The tool again will be the same, 10mm end mill, and the levels, my upper level obviously being over here, but my pocket depth being at the very bottom of the pocket itself over there. The step down will be every 3 millimeters. Now I've added a delta depth of 2 millimeters to go a little past the area on the bottom to cut through the entire area without leaving a burr at the bottom. My technology will be, again, contour, the exact same things over here. And this time, since I'm not working on the floor, I do not need a floor offset, and my finish will be on the wall only. My link, again using a link of helical ramping and an arc lead out. If I take a look again at my simulation now, using the solid verify, you'll see that my tool again will go in, mill out the smaller slot on the bottom until it gets to the very end at the bottom of the part itself. Now, in my next operation, I like to now deal with this area. So I'll be going now to my Mac 1 position 5, working on that area. If I take a top view of the part itself, you see that this is the surface that I want to work on, this hole over here, and this I'll be doing with the pocket, and then drilling out those holes over there as well. So in the first operation that I'll be doing will be the pocket operation, choosing my geometry as shown over here, and my tool will be again the 10mm end mill. My levels, my pocket depth will be up until the floor over there itself, again using technology of contour with a wall offset and a floor offset, and a link in of helical and a lead out of arc. In my following operations after that, I've done a drilling operation where my geometry, again using position 5 is the hole itself over there, as you can see, the center of that hole, using a 10 millimeter center drill, spot drill for this operation. My upper level being this step over here, the top of the floor, and my drill depth being at 0, but having the 9 millimeters of the tool get down to this level over here. And in my next operation, I've just used now a simple drill to finish out that particular hole using a 12 millimeter drill. Technology, my upper level, my drill depth all the way to the bottom. And using a technology of peck drilling as shown here. And we'll set the pecking to go at every 5 millimeters. I'll do a simple save and calculate and then simulate the part itself. Again, using the solid verify simulation on the part. You'll see that the tool will go down and drill out the hole until the very bottom. Now in my last operation, I'll be basically finishing off the part by just simply putting it in a different holding, different position altogether. So we'll be using now Mac 2 position 1 just to do a simple face mill on the other side. And all I have to do is simply go to the operation, and what I've done here using my Mac 2 position 1, having my 16 millimeter end mill, and my technology area basically the exact same way I used my face machining before. Thank you for joining us on InventorCAM Professor. Take care and have a nice day.